All right. Just need to shuffle a few more things around here. This up front. Okay. I think we're ready. So let's do a quick introduction. Hello, everyone. My name is Tim. I go by foamyguy online on Discord and GitHub. This stream, we're going to be working on some CircuitPython library updates for the new version of CircuitPython to fix some of the breaking changes, some of the stuff that's incompatible with the old versions. Taking a step back, though, if you're new to the stream, if you don't know what CircuitPython is, it is a version of Python that runs on these tiny computers called microcontrollers. So this is the website for it, circuitpython.org. You can learn more about it here. Let's see if I can pull up the camera here. I'll show you one of them. I think it's probably going to be 15, hopefully. Yep. And let's do this. Let me fix the focus here as well. And we're going to need to flip that. There we go. And I think I like the light on. Let's do that. Makes it a little easier to see what's going on. So this is one of those microcontrollers right here. This is a Adafruit Clue. So it has a bunch of different sensors and things built into the back of it. You can see some of them labeled here. Accelerometer, gyroscope, temperature pressure sensor, magnetic sensor. There's all kinds of fun things on this. It has Bluetooth connectivity through the main chip. On this device, the main chip is inside of this little metal covered box up here. And there is a screen on the front side of this. So this particular device kind of matches the form factor of the BBC microbit. This is just like a more advanced version of that with a full screen instead of just the NeoPixel LEDs, or I guess those are red LEDs on the microbit. But this is the type of thing that CircuitPython can run on, these tiny little microcontroller devices, which are basically just little computers. And CircuitPython is a way that you can write programs to run on these devices using Python code. So if you're used to Python, then you can get up and running quickly and easily. If you're not used to Python, if you've never done any programming before, or you've never done any Python programming before, the good news for you is that it's super easy to learn compared to lots of programming languages, especially things like C, which traditionally are kind of what you use to program these microcontrollers. So this makes it quite a bit easier and quite a bit quicker in order to iterate through your different designs of your program and stuff. So specifically, we're going to be working today on some of the updates to fix some of the backwards compatible changes, or non-backwards compatible changes, I should say. So we're going to start out with some ULab updates, or microlab is the way it's pronounced. And then once those are out of the way, then we will look at the Turtle library. So the Turtle library got updated for on-disk bitmap changes, and there's some weird stuff going on with it. So we're going to try to troubleshoot that and figure out what is going on inside of there. Let's see. Thank you. Yeah, Dexter, I appreciate the heads up on the audio. And Cornbread Ninja as well on Twitch. Thank you to both of you. Real quick as well, if you are interested in the CircuitPython project, if you want to help support the project, there's a couple of ways you can do it. It is an open source project, so anyone and everyone can help contribute. You can work on the core CircuitPython if you know C code, or if you're good at GitHub kind of process issues and stuff like that. But if you're a little bit newer to programming and you are not quite ready to dive all the way into C yet, which is kind of the state that I'm in. I'm not really new to programming, but I don't really know C that well, so I don't do a whole lot of work in the core. But the other way that you can contribute is to the libraries, and the libraries are all written in Python. So it's, like I said a little bit ago, it's a much easier language to learn and to write than C. And so if you do go to circuitpython.org, there's this contributing link up here. And you can look through all the open pull requests for the libraries and also the open issues. So you can go through the pull request, you can find one that you have the hardware for, or even if you don't have the hardware, you can take a look at the pull request, you can see the changes, you can kind of look over them, make sure that everything looks good, make sure there's no typos, make sure everything makes sense, all of that sort of stuff. If you want to go a little bit deeper, you can look through open issues and you can try to find an issue that interests you, and then you can write the code to solve whatever that issue is, or add the feature if it's a feature request, that sort of thing. So that's one way that you can contribute, is by working on the project in the libraries. Another way that you can contribute is by supporting Adafruit. Adafruit is the company that puts the financial backing into CircuitPython. They pay folks full-time to work on the CircuitPython project. They pay folks to foster the community and to do all of the fun things that we all like to take part in. So if you purchase hardware from them, they sell the microcontrollers, they sell all sorts of sensors and things that you can plug into the microcontrollers. And so you can purchase hardware from them and you are helping support the project in that way. Speaking of Adafruit and the project at large, there is upcoming CircuitPython Day this week, or I guess next week it would be technically. CircuitPython Day, let's pull up the post for that. So this is on Friday of next week, Friday, August the 6th. And so there's a couple of different streams planned for that day. And there's, I think Scott mentioned last night on the deep dive, maybe there will be an AMA on the Python subreddit. So if you're interested in that sort of stuff, keep an eye out for it. For me, on CircuitPython Day, I've got the day off, and I'm planning to stream at 11 a.m. Eastern Time. So that's the same time that I normally stream on Saturdays, but I will be going on Friday next week to celebrate CircuitPython Day. So if you are interested in watching along, you can check me out on Friday, again at 11 a.m. Eastern, or 10 a.m. Central is usually what I say, because I'm in the Central time zone. And so I don't know exactly what we'll be working on yet on CircuitPython Day, but I'm sure it will be something interesting. So let's go ahead and dive in. I think where I'm going to start today is some updates to the Learn Guide code. And specifically, these updates are around ULab or Microlab, which is kind of like Numpy. If you're used to CPython to regular Python, there is this module called Numpy. Let's pull up the Learn Guide for that. Numpy is a library that does a bunch of number processing. It's able to crunch numbers a lot faster than just regular Python code. It can operate on arrays, and it can do all sorts of sort of bulk array operations. And it can do them much quicker than just writing plain Python code can. And so ULab, or Microlab, is the CircuitPython implementation that has a lot of the same functionality as Numpy. So specifically what we are doing is, with the newest versions of Microlab, a bunch of things have been renamed. So they used to be at ULab dot, this is a good example of one of them maybe right here. This says ULab.vector, but most likely this is no longer ULab.vector. It's probably inside of something else now. Like if we, on the REPL, if we go import ULab and we look at dir ULab, it's not going to have a vector here anymore. So most likely this is inside of one of these other sort of package names. So probably, I'm going to guess Numpy. If we were to look at dir ULab Numpy, we'll probably find vector in this one, I'm guessing. There's vectorize. So no, maybe dtype. Let's look in dtype. I don't know what that one is. Deleter, getter, setter. It's not in that one either. SciPy, maybe it's in here. No. I don't know. We'll have to find where that one's at. But the gist of it is that it's no longer, most likely it's no longer ulab.vector. I don't think that probably, so like if we were to try to run this code, ulab.vector.sign, I don't know, just give it a number. So it's no longer there. It says modules not found. So maybe we don't do vector anymore. Maybe it's just this sign right here, which is ulab.numpy.sign. That one works. So that's probably what that gets replaced with. So you can see, from this example, there's quite a few things where they used to just be kind of at the root of numpad of ulab. You could say ulab.vector.whatever, and then it would be inside of there. But a lot of those are now inside of numpy or scipy. So we have to update the all the projects that are using Microlab so that they will point to the new names of everything. So I'm gonna dive into that, and the one that I'm working on first is this Clue Light Painter. So I will pull up the guide for that one specifically, Clue Light Painter. And I'm not 100% sure what this does exactly. Okay, it looks like maybe you turn on the LEDs and then, or maybe this is with the screen. I'm not sure if this is with the screen or if this is with external LEDs. Yeah, actually, it looks like it's going to be external LEDs. So it's based on using an RGB strip, and I think the idea is you can use like a long exposure camera. You can set a camera to like longer exposures, and then you can wave the LEDs in front of it, and it will be able to paint a picture like this by turning certain LEDs on and off and setting the color of those LEDs at certain times as you're waving it across like that. And of course, there's lots of complex math that goes into being able to do this. So that's why this is a perfect use case for ULab, because you could not really crunch all the numbers. You couldn't really do all of that math in Python code. If you try to do it, the CPU would not be able to keep up. And as you sweep across the LEDs, like you probably would not end up with the correct picture coming out, or maybe there would be gaps in it or something like that, just because it wouldn't be able to process fast enough to make each of these columns of pixels as you wipe it across the camera. So basically what we're doing is just looking through the code for this project and finding things that are ulab dot something, and we're changing them to the new name. So we see right here, is this the first one? No, we're like halfway through. Let's go back to the first one. First one's up here, ulab.array. So we need to find the new place for array. I'm guessing probably that one's in NumPy. So ulab.array, I think it's creating an array is probably what that does. Let's see what's inside of it here. It has 4 0 indexes. So if you multiply a list by a number, then you end up getting a list that contains that many copies of that element. So like, if we have a list of 7s and we multiply it by 4, then we end up with a list with 4 7s inside of it. So that's a Python convention. So inside of that array, we've got, looks like 4 zeros plus a bunch of RGB pixel subarrays. This looks like it's going to be an RGB maybe alpha or maybe W, RGBW potentially, times the number of pixels. So we got 4 zeros to start, and then we got a bunch of pixels, and then we got a bunch of 255s times this right here for some reason. Num pixels plus 15 over 16. I'm not sure exactly what that part's about, but the main thing we need to do is find the new spot for array. This is creating an array, I believe. So we can just verify that it does not still have the same name by saying like ulab.array, passing it something similar. So it doesn't really matter exactly what we pass it. I'll just make up some stuff here, and we see, yep, it says module has no attribute array. So probably this is now this numpy array. Yeah. So we want to change that one. NumPy array, and we also have one right here, uint8. I'm guessing is also probably not called that anymore. ulab.uint8. Let's try it. Nope. So let's check. Is that NumPy? Yep, it does appear to be on NumPy. I think that's probably where most of this stuff is going to end up being. So we'll just basically copy that .numpy, paste that right in there, and we're just going to go through and find the rest of the references that use ULab. So this one is called zeros. This one will create an array specifically that's filled with zeros. So you can give it a number for how big you want your array to be, and it will create an array of that size and fill it with zeros for you. So, you know, same thing like we just saw before. It's not going to be like this anymore. This would be the old way to do it, but it says no module, or module doesn't have the attribute. And I am guessing probably, again, the new way is probably this. Yeah, so we see there we got an array. It has 7 elements in it now because I put 7 there, and they're all set to 0.0, and it defaulted to float numbers. So this one is changing it over to ints, but you know, it works the same way regardless of whether you want floats or ints inside there. So we're going to put our .numpy here and here. Yeah, thank you. That's the learn guide for this project. So let's keep going here. Array, we already saw that one, so we know that's in NumPy. Also uint8 here. Let's see what's next. There's another array and another uint8. And that might be the last one. Is that the last one? So I'll just run through these real quick and make sure we got them all. Lab.numpy. Oh, nope, we missed these ones. Okay. Good thing we double checked. So let's keep checking through here. Yeah, I think we got them all now. Okay, so this was one file. This was bitmapped to LED. We just need to check the other files and make sure that there are no other usages. So this is trying to, well, this is bootpy. It's setting the readable, writable state of the storage. There was no ULab usages in there. Let's check CodePy, ULab dot. Nope, we don't got any in here. Rich button. Guessing probably not, but let's check on it. Nope. Okay, so it looks like everything for this project was all inside a bitmap to LED. So I think we got it done now. Well, we searched ULab dot, so we know there's no other instances of ULab dot. I was going to say let's look through the documentation comments, but there must not be any other instances in those because we did search for it. So I think we're good to go. So I think I already created a branch for this. Yeah, Light Painter ULab. I did already create a branch. So we were pretty much ready to push this one. And, you know, I know I just double checked it, but I always do like to check again right before I push just to make sure there's nothing crazy inside of my changes. So essentially what we're seeing is just adding those .numpys. Yep. And nothing else has changed, so that's perfect. We could actually just reuse this maybe. Light Painter. Okay, we're pushing to foamyguy Light Painter ULab, which makes sense. That's exactly where we want to push. So we will do that, and then we'll go make the PR for it. To use the newest version of ULab. Let me see, can we run this code? So I don't have a strip of LEDs that are just ready to go, so I'm not going to be able to test this on the stream right now. Let's take a look through the guide real quick and see how you actually run this thing. Build the paint stick. Oh yeah, I don't... So it requires you to kind of get a whole stick laid out there. So I'm probably not going to be able to test this one. I do have LED strips, so I could maybe just run the code. I could run the code and make sure that it doesn't crash. But I'm not going to be able to test the full thing because I don't have whatever these poles are, and I'm not going to be setting up this entire hardware project. So I'll just leave a note here in the PR. Don't have the hardware set up to test this. Okay, yeah, we'll just leave it like that, I think. Maybe I'll come back and attach a strip and just run it and make sure that it doesn't crash, but I probably will not get to test the full thing, so. Okay, this is all looking good, so we're gonna go create. Okay. I'm gonna leave this tab open and wait for the actions to pass. As long as the actions pass, then I'll tag Anne. Anne has been doing the reviews and the merges on some of these CircuitPython 7 breaking changes, so. But I will wait for the actions to pass, just in case if they don't pass. That way I haven't requested a review yet. I can go back and fix whatever needs to be fixed. So now we're just gonna keep going down the list, basically. I have a spreadsheet which has these things in it. I don't know, is it gonna let me see it on this? Yeah, not really, because I'm not signed into the right account. Maybe I'll just do this for now. So light painter, we just did. Metal detector, I actually did earlier today, so that one's done as well. Ocean resin light box, we'll do that one next. I'm gonna add like a completed X's to these, just so I know they're done. Maybe center the text in this column, if I can do that. Okay, so ocean resin. Let's get the learn guide for that, and then we'll find it in the repo as well. Ocean. That's probably it right there. Reshuffle the windows here real quick. I can have the chat back, all right. Okay, so let's see what this one does. This is another one I'm not gonna have the hardware to test the full thing. But maybe if it's just a strip or something, maybe we can do something similar to like we did before, or like I was talking about doing before, I guess. Not sure if this uses a matrix portal or... Okay, so this is like the resining process. This thing actually looks really cool. I like the way it turned out for sure. Let's look at hardware. Ah, yes. So maybe not a matrix portal specifically, but it is the matrix. So it looks like it's plugged into a feather or something else, but it is using that big RGB matrix. And yeah, they say here feather M4. So let's go to the code page. Oh, you know what we need to do actually? We need to go back to the light painter guide real quick. And we need to check if there's any instances in the guide that need to be updated. Let me do that. ulab dot. Okay, so we did not find any. So is there any ulab at all? No, it doesn't look like it. Let's check here. ulab. Nope, nothing here either. Python magic. ulab. Math shenanigans. Okay, let's take a quick peek through here. Process. Okay, yep, looks like that's all we got there. So none of the actual like code snippets do contain any of the ULab code, so we won't really need to update any of those code snippets, it's looking like. Let's just double check here. Yeah, we're looking good on that one as well. Okay. I think we are good on this one. I'll check out this one next, the ocean spray, so ULab. And this is the GitHub embed. So that one's going to change automatically. So we don't need to update that in the guide. Here we've got some that we'll need to change. Yeah, so zeros right there we saw before. That's now .numpy.zeros. .array we saw before as well. That's now numpy.array. uint8 we also saw. And it looks like that's all of them on this page. So we'll need to come back and change those. Anything else? GB matrix. That looks like that's it. So let's do the code inside the repo. And this is called what? Ocean. We can link to it from here, actually. Let's go back to here. Let's go click this GitHub link. This way we can find the folder it's in. So it's called Ocean Resin Lightbox. Oops, too far. There we go. README, let's look in the README as well. Is there, no, okay, this is mostly like just copyright, no link and stuff. Lab dot. Still have that pasted? No. So that was .numpy. Okay, so it looks like we found 3 instances and we got them all updated. So we'll save that. Let's push it. Was it iron resin? I'm not very good at spelling things sometimes. Yeah. Okay. Foamyguy, light painter. Oh no, we don't want to go there. Oh, you know what? That's a bummer. Should not have done that. So I just, did I just push that? Okay, well no. I made the commit, but it hasn't pushed yet. So I should not have made the commit, but the good news is that at least it's not pushed. So could just not worry about it. But I think I'd rather undo it if it's easy. Maybe this will let me undo it. So basically I didn't make a new branch yet, and I should have before I committed that. Let's undo that. And yeah, now we're good. This is back to blue, which means it has changes that are waiting to be committed. These have the numpys back. And so we need to make a branch. Git checkout -b. This is the ocean resin ulab. No track. Okay, that's better. Now we want to push to this branch. Okay, foamyguy ocean resin ulab, which makes sense now. Yeah, that's good. Okay. Push that. And now we go make the PR, and then we'll also update the guide pages. Version. I'm gonna go here. That was on the explanation page. Okay. Changes look good. So let's change that guide page. Maybe I can't change that guide page actually. Oh, I'm not logged in. Let's go here. Factor. Okay. This is not where I need to be though. We need 2 factors. Okay. Okay. Oops. Wrong page. Actually, we could go to that page again. It's code explanation. Edit. So ulab dot. Numpy. And array right here. And uint 8 right here. So those were the 3. We had only 3 changes. Pretty sure. That one's good. That one's good. That one's good. And those are the only 3. So now we're done with that. Just make sure the live page is good as well. I think it should be, but definitely a double checker. Yep, looking good. Okay. Okay, we'll leave a note that says we didn't test it. Maybe we could try to adapt it. I have, yeah, no worries. See you, David. Thanks for tuning in. I have a matrix. I could try to hook it up to my matrix. I don't know if I have the feather thing specifically though. I've got the matrix portal. Could maybe be adapted to run on that. Looks like this passed action, so I am gonna go ahead and tag Ann. I'll close that for now. We'll do the same thing on this one. We'll wait for it to pass actions, and then once it does, we'll go back and tag Ann. All right, so next one, let's go back to the spreadsheet. Okay, we got this one. Ukulele. Lab.numerical. Ukulele. There. Okay. Let's link out to GitHub. Let's also search while we're here. Matches and extras as well. So those are the only two. I don't know where those are at. So we'll go back to the device here and try to find those. The numerical, I don't think numerical exists anymore. Oh yeah, FFT to detect the notes, that's cool. Yeah, that's another one of the things you can do with the Numpy stuff is kind of process the process incoming sound. Figure out what note it is for, like, if you're trying to auto-tune it or if you're trying to set up lights to change based on the notes, stuff like that. So ULab extras. You know, the other thing I have pulled up, which I should get in this browser, is this page here. Which is the docs page, extras. Oh, there is no extras anymore, doesn't seem like. Let's take a closer look at what it's doing. So this is in the folder ukulele. It also imports ULab as MP. This one might actually have quite a lot of updates. Yeah, because like this would need to change as well. Actually, that's the only instance of NP, so. Okay. Spectrogram. Okay, let's look at this one too. Argmax. So we need to find argmax and spectrogram, and we already know where array is at. So p.array. So we already know this one is here. Extras dot. Well, okay, so we have actually two problems, or not problems, but two things we need to fix are that this import most likely is not going to work. And even if we fix the import, we also need to fix the code where it's used. We can do that. Yeah, I don't have any real experience with Numpy, truthfully, so I would definitely bow to other folks on that one. Numpy. And then if we find it, np dot. I think that should work. Let's just make sure though in the REPL. Let's get a new REPL though. And I guess we just give it something here, right? Yeah, okay, that worked. Yeah, thank you for that convention. Like I said, I don't really have much experience with it, so I definitely appreciate having folks who know a little bit more about how it's used normally. So extras, this is probably not going to work, I'm guessing, right? Yeah. So really, I suspect there's probably nothing called extras anymore. It's probably just spectrogram now, I'm guessing. It's exp, mp1, I, fft, yeah. We need to find spectrogram. Which is also not here, spectrogram. So let's check SciPy. Optimize signal special. Is it on one of these? There it is. Lab SciPy signal spectrogram. So I think we should just get rid of extras. Just call spectrogram and say ULab SciPy, was it signals? Signal spectrogram. No, that's not the right way. So actually from import no, spelled it wrong. Trogram, spectrogram, TRO. Let's copy paste it. So I noticed that pasting in the REPL on the clue sometimes leaves out characters. Samples is a numpad array, a numpy array. So we'll need to import more things actually. Let's go. Work? Yeah, that worked. Okay. I don't know if there's a difference between those, but was the way I tried it, so I'm actually going to make this match. So I know for sure that works. Okay, and so the other thing, what was the other thing we need to find is argmax. Argmax. Let's get a new REPL. Argmax right there. So that one's just on Numpy. So we could actually just say NP. Because that's now inside of Numpy, argmax. So if we had this, see, it got rid of the R even though I copy pasted. Wow, that time it got almost nothing. Wow, it's really bad. Oh. Okay, we just can't paste. We can't paste. Yeah. Okay. np.argmax np.array I don't know what argmax does. That's kind of interesting that it was a 1 though. What does argmax do? Let's look in the docs. Curious. Argmax returns the index of the maximum element in the 1D array. Yeah, index 1. So if we did the same thing, but this was lower than 9, then we would get index 2. Yeah. Okay. We don't need this. We have spectrogram. This doesn't have usages. Why does this not have usages? Spell it wrong again? No. This doesn't know that that's a usage for some reason. Okay. Weird. Okay. p.array and p.argmax. Okay. I think we are good on this one. And since we changed around the names of some of the things, like getting rid of extras and numerical, I think I would rather, instead of just editing the guide by hand, I would rather push this and be able to copy paste the lines of code. So let's push it. What does this one run on? We need hardware to run it? Feather. Feather with some neopixels and a battery. that a feather STM or feather sense? Oh, also this, yeah, no, I don't have this, I don't think. What is that? Prop maker featherwing, maybe? Hardware will be on overview. Yeah, prop maker featherwing. I don't. Do I have one of those? I don't think I have one of those, but I might. Well, let's see. Have I purchased it? No, yeah, it would say up here if I had purchased it before. So we won't be able to test this one either. We tested it in the REPL though. I think the important part is we made sure that those imports work and those function calls work. Okay, let's not do the same thing we did last time. In fact, I should really start making a branch before I start making changes. Let's go check out ukulele lab. Spectrogram because we import it directly. Argmax is now on Numpy. Where was array? Shouldn't we had an array somewhere, I thought. Oh, it already was np.array and we just changed it. We just changed the import to make it work. Yeah. Okay, that makes sense. Okay. foamyguy ukulele ulab. Push. Okay, I'm gonna go back here, make the PR. So this is the GitHub embed. So this will change automatically whenever the PR gets merged. That's the same thing I was just on. Which is still the GitHub embed. Very long GitHub embed. Yeah. So actually it looks like there will not need to be... Ah. This one does change. And this is still the embed. It was only found once. So the only place where spectrogram is in the embed. That'll update automatically. But argmax, there's one more spot for it in the snippet down here. So let's update that actually. already click edit? Yeah, okay, I already clicked edit. Artmax. Needed updating this page. New code from this PR. Do not have the specific number required for testing the full project, but I did run specific lines of code that were changed in REPL. Verify that they work as intended. PDM microphone breakout. Yeah, I agree. It does look like a super cool project. It'd be a fun one to set up. Okay. Spelled occurred wrong. Well, I guess I did request a review before the actions passed. That's alright though. This one is passed now. Okay. Next one. Oh, these are all part of that actually. Lab crunch numbers fast. Benchmark. Next one down. Okay. So we got mean, sum, array, STD, probably standard deviation. And also numerical. Oh. So I think this is extra, right? We don't need to import ulab and then also import ulab.numerical because nothing is using just okay, yeah, array. I don't know why that does that. I wish I could just turn that off. I never want to move code with my mouse. Okay, we do need to import both. So we need to find mean and sum and STD. My guess is those are all on Numpy. There's STD. There's no sum. There's mean. So where is sum? That's the wrong thing. Let's look in the docs for sum. Did I miss it? It says ulab.numpy.sum. Uh-oh. Doesn't show up in dir, but it is in the docs. So ulab, well, let's go print ulab.numpy.sum. I guess this probably needs to be in a ulab array or a numpy array or whatever. Array. Huh. Why would that not show up under dir if it's still there? It was on the first line. Oh, they're not alphabetical. Thank you. Thank you. Yeah. Okay. They're like almost alphabetical. They're alphabetical except for the first 5 or whatever. Yeah. That is weird. Okay. Whew. Okay. So those are all on NumPy. We found std, mean, and sum. They're all here. So this code will be... we can test this one too, actually, because we can run this. I think, right? Yeah. Should be able to run this. Doesn't even look like... Honestly, this doesn't look like it uses any kind of hardware or anything. So let's go... So really we just need ulab.numpy. We don't need this anymore. And then this is NumPy, this is NumPy, this is NumPy, this is NumPy, and this is NumPy. I have TO up. Yeah, I guess I've been using REPL. Of course I have TO up. Yeah. Looks like it ran. Maybe we could, I guess I should have ran it before I changed it, maybe also. That way we could just see that it crashes. Yep. What is this doing? Computing RMS of 100 numbers. Traditional takes 9 seconds. That can't be true though, because this didn't take 9 seconds to run. Oh, 9 milliseconds. 9 milliseconds. Okay. Yeah, that makes sense. With Python code, it took 9 milliseconds. With ulab list, it took only almost 4 milliseconds, and with nd array, it got down again to like 3.5. With this one, it took 4.1. Interesting. So that's should be the only one. Are there no uses? Oh no, this should have some uses. Yeah, there's some more uses here. I don't know why. I don't know why these weren't on my list. Where'd my list go? There's too many tabs open. Yeah, that's really weird actually, because ukulele it had each one listed out as a separate one, but this one only has benchmark. So maybe we should also grep. So I did not take my own advice from last time. Make a new branch, let's do that. Branch, numbers, fast, lab. Yeah, there was a bunch of these actually that didn't show up. Well, maybe not a bunch, I guess, actually. Why, these are repeating. Q. Okay, so we'll need to do this one as well. Let me add these actually. Binary file. I'll test this, but I don't think we can change a UF2. Well, I don't know how to change a UF2. We'll see what's going on with that. I did metal detector earlier. We got light painter. Another UF2. I don't know, what are these skipping? Why this stuff's not in order? Pygame we got. Ocean resin we got. Expressive eyes we already did. I mean, we already copied. Metal detector, light painter. Resin light box. Expressive eyes. It found the same thing a bunch of times. Metal detector, light painter. Light painter, resin box. Expressive eyes, metal detector, light painter. Serial pass through I just copied. Expressive eyes, metal detector, light painter. Pass through, metal detector, light painter. Pass through, light painter. Pass through. Okay, that looks like all of them. I don't know why a bunch of them got repeated a bunch of times, but we got them all now. So let's work on the rest of the ones in number crunch. Clue barometer. I have the clue right here, so we could test this one. We'll need to find whatever was in filter. This one we already know is .numpy. And this one too. .roll in sum. This is roll in NumPy. Yeah, roll. Sum we found before, I think, right? Yeah, that one's there. Filtered. Huh, why did it import this? Doesn't seem like it's used. Load floor from full. No filter here either. I think it's gonna work without that though, because it's not actually trying to use it. Doesn't find any more than just the one. Array, numpy zeros, numpy roll, numpy sum. It seems okay. Stack exhausted. I don't know if there's anything we can do about that. Insert pressure. Well, we can't test this one. So what we could do is we can go back to 630 and see if this runs. See if the changes are related to this update, or was it already not working before this? Wish this scroll bar was bigger. Okay. So I'm gonna double tap reset. Go to bootloader. Go back to 630. And we're gonna get the old version of this. And I guess it's not going to work because this will be on the wrong version now. Does this work for downgrades also? Yeah, it looks like it. Same problem. So let's go down this rabbit hole just a little bit farther. Let's go to the library for BMP 2080, 280. See if the simple test works. it right here. Yeah. Let's see if it works if we turn these things. Does. Okay. So it's not a problem with the sensor library, just something to do with that full ULab example is running out of memory. PyStack. And I don't know if there's anything I'm going to be able to do about that. I mean, this giant array, well, but it's a numpad array. I don't know what is taking up the most space. This big array maybe is taking up a fair amount of space though, because these are all big floats. Is there anything special about how many of these there are? 311 apps. So this makes a zeros array based on the length of taps. It says data times taps. Let's look at the guide. I don't actually know what this is doing. Oh, maybe that's this one. That looks cool though. Benchmark. Now this says waterfall. Waterfall. LED wave. Oh. Oh. This is a different sensor. Blue pulse. Here we go. Yeah, it does have this big array. Okay, this is the one. Short estimation example, we'll use a filter to remove the low frequency, slow changing part of the signal to preserve the high frequency. So as a high pass filter to measure barometric pressure, we instead want to preserve the slowly changing part of the signal and exclude the quickly changing part. Blue or feather sense. I have a feather sense. Maybe if it's not importing display IO, maybe it would save some memory. Hello, Samurai. Barometric pressure is offset by 980. Huh. So I don't really understand what the what this big array does. I wonder if we can just make it smaller. That seems kind of ham-fisted a little bit, but I wonder, like, if we just cut out like that many of them. Gotta run it. Yeah, now it's working fine. Okay. Although it is, it's meant for the, what is it, Control TQ? Yeah. It's meant for this, right? Yeah, there we go. Is Jeff online? Go away, search. Jeff is online. Maybe I'll ask Jeff. Metric pressure example. Exhausted. It's out of there. Cat's trying to get into things. Okay. See what Jeff says. For now, we'll just stick with the... Actually, let me also put a little bit more information. Probably overtaking the chat, aren't I? Yeah. Switch it back to live broadcast in a minute. I don't like to keep multiple Discords up because then I get confused about which one's which. Sometimes type into the wrong one or sometimes move the wrong one to the wrong place. Try splitting the big list, so arbitrarily break it into 2, 3, or 4 parts. Do that. Okay, let me go back. That would make sense, I guess, right? Because then it could be... It could take smaller chunks in memory. So maybe the problem is that we're not like out of memory altogether, but the problem is we're out of contiguous one big chunk of memory. So that could make sense, actually. Glad I asked, because I would not have thought of that. So let's go back to where this has everything. And let's just try splitting it into a couple. Plus here. And I'll just aim for like roughly thirds-ish. Oh, that last third is a little bit bigger, isn't it? Let's make it 4. Make it 4. Let's do one more. Feeling lucky with 4. Plus here. Okay. I think we got that right. Ah, yeah, that seems to do it. I didn't know you could have these both open. I don't use the serial plotter very much. I didn't know you could have both of these open, though. That's cool. Okay, so we'll make that change in this PR also. Go back to live broadcast. Okay, we could close these. I'll copy this to the repo. That's a neat trick. I'm glad I asked because I never would have even thought of that. Not in a million years. Well, maybe in a million years. I don't know. It's a long time. I would have got hungry in a million years, so I definitely would have had to have a snack. That's a neat trick. What are these? Oh. Does Pilot run on this repo? I don't remember. I don't know. I don't know if this is Pilot like from the Pilot RC or if this is just PyCharm. Like PyCharm has its own Pilot check-in. Sometimes it doesn't always match what the Pilot RC says. I've noticed. Is there anything else? No. Alright, so we updated that. Did we make the rest of the changes? Yeah, Numpy. I think we're good now, right? So just to double check, let's take the code from the repo and drop it back on the clue. Okay, not good now. Oh, right. We're on We're on 630, so let's go back to 7. So, do it on the camera, I guess. Let's go double tap, reset, got it. Downloads, scooch this back over. Let's go find that UF2 for, well, maybe we could do this, clue. Huh. 3, I should delete some of these, my goodness, I need to clean this thing up. Feather. Okay. We're back on 7005. It doesn't seem to be running. Should not be running. Right, because all the MPY files are now back to 6. So we need to run this again. Also, I typed to the chat accidentally. Yeah, it's a good question, Dexter. Okay, so we did not fix all of the things correctly. So I'm glad we tested. Said line 17, I think, array. Oh, duh, yeah, right, this big ass, excuse me, this big list of arrays. So we need to fix that. Let's fix it. ulab numpy here. That should do it, I think. There we go. Ooh. I made another coffee before I started. Alright, so yeah, we're running now. We got our graph. I assume that's what it's supposed to look like. Like I mentioned to Jeff, if anybody saw it, I don't really follow exactly what it's doing. I mean, it's taking readings of pressure, but... Oh, okay, so it's just, I mean, it's like smoothing it then, right? It's basically just... The blue line is the raw readings, and the green line is using this technique to crunch it and like average it. Is that what's going on here, I think? Barometric pressure, so if I raise this higher up into the air, it should go up. I don't know if it's that sensitive though. Is it that sensitive? Or would it go down? Looks like it went down. Does seem like it made a difference though, right? Like my blue line is way lower now. The green line didn't really change though. Now the green line is all the way over the blue line. So maybe my understanding of that is not quite right. So if I put it back down here, yeah, that is interesting. You can definitely see the difference in the, I mean, altitude basically, right? Like, difference in pressure from altitude, but I think I get what the green line is. Let me read through this again. Because in this picture, Well, so I have dark mode, I guess, which is probably swapping it, right? Yeah. Light mode, the green line is jaggedy, and the blue line is smoother. But my blue line is pretty much straight. Does that just mean pressure is more even where I'm at? Notice how the blue trace is smoother than the green, but it's also moved further to the right. "10 seconds, okay. So it wouldn't update the smoother line for about 10 seconds. Still seem to be pretty much straight the whole time, though. Raise this back up again. This as high as I can. So I could take it upstairs. Well, not with it plugged in, I can't. Okay, I know what we'll do is, we're gonna have to undo some of the stuff we just did in the last minute, but we're gonna go back to the old version, 630, and make sure it behaves the same. That way we can know that I didn't mess it up by changing anything. As long as it behaves the same on 630 as it does 7. That's really the most important part for what I'm doing. Yeah, my blue line does seem to be pretty much just straight. Huh. Okay. Let me put this back. Let me go back to dark mode. Okay, this is the 630 version. I'm gonna save it. It's gonna crash. We're gonna go back to bootloader. Gonna copy 630 back. Oh. And in Hamming Windows. Let me pull this up. Hmm. This is interesting, but definitely a bit over my head still. So he used this, I think he used this equation to get that big list of numbers, basically, if I'm understanding correctly. No, you can't do absolute mouse. Sorry, this is unrelated to anything I've been talking about. I just saw it pop up in the chat. But I'm pretty sure I know the answer to it. Let me switch back to live broadcast. So, mice don't know. I'm pretty sure at least mice, like HID mice, it doesn't know where it's at, XY. It only knows when it moves. And it only knows like it moved by a certain amount. Oh, this person says they made an absolute one though. Oh, that's good though. They're not actually asking about it. They're just saying they found it. And I actually looked into this a little bit for a project I was trying to do. I was trying to make it click something specific on the screen. I was like, I know the XY location. Can I just make the mouse move there? And the problem was, at least when I looked into it, what I understood was that the mouse, it doesn't know the XY coordinates it's at. It only knows when it moves. So what I ended up doing was like shove it to the top left corner a lot, just like a gigantic value, and then that made sure I was at 0, 0. Then from there you could move it. I don't know if that's what this is talking about though. Maybe this is a different thing. Yeah, that's true. The speed doesn't know either. It just sends in like it sends in like XY change. Like we changed by this amount of X and this amount of Y, and then it's up to the OS to do with that what it will. I guess maybe this is like helper code to do some of that. Yeah. It's basically, they did the same thing, it looks like, that I did. I mean, they chose bottom right instead of top left, but it seems like the same concept. Yeah. Interesting. Okay. So this was pasting CircuitPython 630, which is going to put all of our libraries back. I should have been running this while I was going on that tangent, but oh well. Oh, shoving it, yeah, because if it was on super slow or something, then you wouldn't know if you actually made it to the corner. That's a good point. I just chose a big enough number. Well, in my case, two things, actually. I was on Android. I don't think it supports different speeds. And the other thing is you could just use a big enough number, right? As long as the OS won't let you go like so insanely slow that you just use a giant number that it can't make it to the corner. Which hopefully the OS will have like, you know, a few choices or whatever. Oh, I see what you're saying. Right, because if it's on a different speed, then you end up at a different location. Yeah, that's a good point. So it can't work like across systems, basically. That's a good point. Luckily, I just needed it on my one Android thing. And I just did the measurements to figure out how many XY mouse movements got me to the right location. That's a good point, though. Okay, this is updated. This is back to the old code. Whoa. Oh no, this is the wrong code. Okay, yeah, this is the simple test. So actually, we're gonna copy from here. We're gonna have to put those breaks in the array back, right? This will be PyStack exhausted. Whoops. Okay. See you, Dexter. This does seem like the green line is pretty much straight across for me here as well. Got my wires all tangled up now. If I raise it up, do anything different? No. So my guess is I'm just not getting enough variance. Like my pressure difference where I'm at here, trying to raise it up as tall as I can, just is not making enough of a difference for the green line once it gets smoothed to really show different. Yeah, I would think the funhouse should be able to run it. That's my guess, though. But the important thing is that it's behaving the same on both. So, if there is a problem with it, the problem does not appear to be related to changes I made for ULab. So now we're gonna do those things again to go back to 7, because we do really want to be on 7. And then after this, we're done switching back and forth, hopefully. All right. I don't know if I'll get to the turtle stuff today. Took a little bit of a tangent. This ULab stuff there's ended up being more ULab stuff than I thought as well. Actually, I made it through the rest of my list, but there's actually some that weren't on my list, so I'm gonna fix those up as well. Maybe I'll do the turtle stuff on CircuitPython Day, or the other thing is man, I hope it comes in. It's the right one, but I ordered one of those. I ordered one of those TI calculators that has the build, some kind of custom build of CircuitPython on there. So maybe I'll bust that thing out and play around with it a little bit on CircuitPython Day as well. Okay, so we want to go back to this one, which was updated to seven Numpy stuff. I want to make sure this runs, but it's going to crash because of our MPY files, so we're going to do this to put those back. I am really glad that CircuitPython does all of this stuff so much quicker. I forgot who it was. My apologies for whoever said how to do this CircuitPython update all, but I really appreciate that little tip. I've been using this a bunch since I learned this like last week or the week before, whatever that was. Okay, this is running now. Yeah, seems good. Yeah, it's a good question. There's a surprising amount of cities that share names in the US. Even cities with weird names, there's usually multiples. I got interested in that one day and looked into a bunch of them. Oh, where did our device go? That's not good. Huh. Device reset? That was weird. Oh, this chooses the order. Raise this up. Still seems to be doing the same thing. It may just be the barometric pressure around me is not that varied, truthfully. Because, like, even my blue line, which is jaggedy, is, it's only getting down to, like negative 2.5 or something. And that's when I lifted it all the way up. Whereas here, I guess that part's about the same, truthfully. This went up to about 2.5 as well. But I took the code unedited, tested on 630, and it looked the same. Yeah, I don't know. Doesn't seem like my smooth line moves very much, but it does work the same in the updated one as it did in the previous one, so I'm gonna count it as good for now. Okay. Back to 7. We're running it. It's printing. Definitely on 7. We're on the updated code. It's not crashing. I think we're finally good on this one. Blue pulse. Maybe it's the way we remove this? Maybe we should put that back. Well, but not because I ran the unedited code on 630, and it had that. Maybe we should put it back anyway? I don't get how it could be doing anything, though, if it's just imported and never... Well, and also we can't put it back because it will crash. Yeah, we can't put it back because it will crash. So is it somewhere? Is it in Signal or something? Okay. I'm gonna do a little more digging. Let me go back to the old docs. Let me actually go back to the old docs. Nice. I would visit Philadelphia, PA, and Oregon. Nice. Yeah, thank you, Neradoc. I've used it a bunch in the last week. The update specifically is super nice. Okay, I don't like the way this highlights after you search. Sure. Oh, hey. This is maybe how they, I don't know if Jeff ever answered. Oh, so that was Dexter, I think, which is who left, right? But, oh yeah, Jeff did answer. And also Dexter's gone now, but if Dexter watches this in the future, this part right here talks about using SciPy on the on CPython to generate that list of coefficients. But I'm still confused why these things import ulab.filter and then don't seem to do anything with it. Maybe I'll ask Jeff about this as well. No, I have not talked to Zoltan. I haven't worked on the main ULab guide either, though, yet. The only ones I've worked on so far are the Learn Guide projects that I've updated. Although I guess I am working on the number crunching one now, which is kind of like the main one. But I haven't changed anything in the guide, and I haven't even pushed my commit yet. Shouldn't do this over here. And matches. There has sort of above in sensor filtering. This to disable, comment, the filter. It says filtered equals numerical.sum. Right, filtered, which is this variable. Glad that my thought to raise it up and down was right. Is this running? Oh, did I go back to TO? No. Am I in the REPL? I am in the REPL. We'll do this. Put it all the way up. We'll count to about 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Give it one extra second here. We're going to take it back down. Set it on my desk. Get the wire back under control. Not sure what that means. Let this run another second and then I'll take a screenshot. Doesn't seem right. You change it so the average of the jagged line is plus 0.2 from what it was before. Right. Okay, yeah, I do get that. I do get that. I mean, basically, if the jagged line is moving, then the smooth line should also be moving, which definitely makes sense to me. Oh wow, look, this went way down, even though it's still just sitting on my desk. This is the update. We'll just throw this in gist for right now. Is this the name? I can never remember. This is not the name. Oh boy, now I've done it. We've got our two discords now. Okay, let me close this ULab. No, ULab, jeez. Okay. Been in ULab world for a little too long now. Let me close this Discord. Okay, well, I'm glad that my instincts were right, that that didn't seem to be working, and that I brought it to Jeff's attention, because Jeff will have a much better chance of understanding what's going on and trying to fix it than I will, truthfully. So where was I at before all that? Actually, you know what? I need to take one quick break and run to the restroom real quick. That's what I'm gonna do. I'll be right back in 1 minute. I'm gonna fill up my water too. Okay. Here we go again. this back because I don't hear that song. Gonna bring the chat back. It's like a cat trying to get into something, but hopefully not anything too bad. Otherwise added as the next example. Alright, maybe we'll see what Jeff's gonna say here. Sorry, I'm hiding the live broadcast chat. Looks like you have to assign the result calling roll. It's the same in Numpy. So this says what in down here? Oh, assign the result. Data equals. So we could take this. Oh, okay, he changed it to NP, but this would be data equals. Okay, so then if this is data equals, save it. Oh yeah, there's definitely more variance in the first number now. I don't see it in the chart just yet, but our chart's very small, right? Let's go like this. Let's raise it. And we do have to wait like 10 seconds, it says, for it to catch up. Oh yeah, it's slowly moving now. This came down to match it. And I guess in another 10 seconds we'll get another little spike for that, maybe? Or maybe that's too small of a spike and it'll get filtered out. But if I put this down back on my desk, blue line goes up, we wait about 10 seconds, and then the green line will go up. Yeah. Cool. Okay, so that seems to do it. Cool. All right. I wonder if he changed this to NP? Yeah, that's a good question. I don't know. I mean, it must have worked at some point, right? Because there's a picture of it in the guide, isn't there? Yeah. Okay. Ooh, I'm gonna need that coffee pretty soon, probably. Well, I don't know. I don't need that coffee, but coffee sure sounds good. Yes, this was from a little while ago. Sorry, I had the chat switched over. Lay Samurai, it does run without that import. And Jeff did mention that that was probably just leftover extra. And David was wondering in the car if there was some trick. Yeah, definitely there is. You can, I don't know if it's that one exactly. The way we've done it in a few of the guides was from import. So I didn't do it in this one. Let me look at ukulele, which we worked on probably while you were gone, David. But this one, well, okay, this went back to main. Let me go look at the PR. I'll show you on the PR. Maybe this one too. Let's look at this one. No, this one says ulab dot. Let me look at ukulele. So here we had from ulab import numpy, and then we did as np. It seems like that np is a commonly used thing for importing numpy. So then this way you can get numpy as np, and then like if you use that same convention in your CPython code, you know, the rest of your program would be the same. The import will be different, obviously, because there's no ulab in CPython, but you could do like try catch if you wanted to make code that worked in both. So yes, there is a trick to doing it that way. That was also from a while ago. Sorry, I had the chat switched over for a little bit there. Yeah. Maybe it does work with the dot too. I switched it to the from because that's the way I tried it, but yeah. I don't know if it was a limitation or not, but I did switch it to the from instead of the dot. We could try it though. Let's try it. We're already in this rabbit hole. We might as well try it, right? Let's go here. So import ulab.numpy as np. That seems to work. Yeah, that seems to work. Looks like both work. Okay. Oh boy, sorry for my yawns. I'm probably gonna wrap up before too long here. But I'll try to finish off the rest of these things. So we got barometer. Do we want to change it to be that way? Might as well, I guess, while we're here, right? Oh, you know what? Did I do it as np? Oh, yeah, I did. It works still. ulab.numpy as np. This will make the code more concise also. Oh, this isn't fixed yet either. Okay. So we're gonna run this one more time because I've changed it a bunch now. Well, I mean, not a bunch, but more than I'm comfortable just assuming works. Okay, see? It's a good thing we changed it. Or, I mean, it's a good thing we ran it. I forgot this one up here, which I also forgot last time. P. There we go. So let's fix that. Actually, let's just copy paste. So that's going to be deleted now, which is a bummer. Let's go back and undo it. Undo. Okay. This one is good now. Clue barometer is out of the way. So let's do clue pulse next. And this has the same thing where filter does not really get used, right? Filter, it's only found one spot, which is in the import, so we don't need this. We could do this the same way. Numpy as np. np. So this is nice because all the spots we need to change are red. So zeros, we've already seen that is on NumPy. Roll, this is just on NumPy directly. Sum also. And also we're probably gonna have to do the same thing here, I'm guessing, right? That gets all of them. Looks like. Let's run this one. Let's take out this extra line. Not sure what this one's supposed to do though. Is it, do I need to like put my finger by it or something? Let's read about this. Oh, where's the guide page? It is. Pulse rate. If it's picking up a pulse. So maybe it doesn't do anything. Yeah, wait for the user to put finger, so that's why it's not doing anything. I'm gonna put my finger on it. Maybe we'll go like we'll go like this. Now it started doing stuff. I don't know really which part of my finger it wants. Seems like when I move it. So is that 36? Is that its estimation for pulse? Try my thumb. I like move around a bunch, bounce up and down on my ball here, my pulse will go up. I make a conscious effort to just sit still and relax. Slow it back down. I don't know if that's in beats per minute. Yeah. Yep, I'm pretty sure that's how it works. It's shining that light in there, and then it's using the image, basically, that it gets back from that little proximity sensor, because that thing's like a 1-pixel camera or whatever. So that one does seem to be working. Is there an output for what it's supposed to look like? One thing I noticed is that some of these values went really, really high, which caused the chart to be, because like the chart tries to size itself to fit the values, right? And so with those really huge values in it, it's making it so that we're not really seeing like the up and down of the blue line. I don't know. Maybe if I okay, let's let it run like this. I'm gonna put it back. Sorry, I know the camera's not up anymore. Yeah, that's what I'm headed for, is gonna close and reopen. So I'm gonna do it after that big spike runs off. Maybe. I'm gonna try to. This is the wrong one. There we go. Yeah. So yeah, now we can see it much closer. So I wonder though, we're not getting like the actual pulses really, like this one shows kind of. But this does describe what we're seeing, somewhat irregular. Let me try putting that roll back. Maybe this one was supposed to not be data equals. Let's just make sure. Just make sure that this breaks how we expect it to, which is that one of the lines won't follow. So I'm gonna put my finger on it first, then I'm gonna open it up. Oh, we don't even have the blue line. Is the green line still moving? If I bounce around, will it go up? No, yeah, that seems broken. Okay. Oh, it went down. But the blue line is gone, so definitely does not seem like it's working. Pretty sure we do need this. Yeah. Now we got both. Of course, our chart's nice and wide now, so should be using my left hand on the reader. Yeah. There we go. So we pretty much have what there's in the guide. We have jagged on the one line, and then we have the estimated pulse in the other line. Cool. All right. So I think we got this one. Did I change anything else? Okay, I already got that. The rest of that looks good. LED wave. This one we won't be able to test. I don't have a 96 string of neopixels ready to go. I don't even think I have a string of 96, honestly. That's a lot for one string. I don't think I have one that dense. Let's check if this is used anywhere. Ooh, this one actually is, yeah, convolve. So we'll need to find that. I'll go ahead and update this to be the same. So convolve, we need to find convolve. Yeah, duh. Yep, convolve, it's on Numpy now. So we actually don't need another import. Lens space, that's probably on Numpy. We should check it though. Yep. Okay, we have no other uses. And so I don't have a great way to test this one. I mean, I guess it won't crash, right? We could just run it, can we? Oh, that's a different change. That's another one of the changes, right? Pixel buff, this is now this? Maybe? No. This got renamed also, I think. I remember Katney talking about this. Pixel buff. Anybody know where wheel is at now? Let's look here. Yeah, that's what... Oh, did I miss a pi? Well, I think Adafruit pixel buff with no pi, but then pi pixel buff, that exists as well. That is the Python library that implements the same logic, which is used on the boards that don't have enough room to fit it inside of the core, like the Teensy, basically, and the other really small M0s. Yeah, pixel buff is this one. What I don't know though is where did wheel end up? Is wheel... And here, the plan is here. The library, this library, pixel buff will remain intact. Ensure backwards compatibility. Will not be moving color wheel. Color wheel will be removed from the new pixel buff, the core one, and it will be added to its own native module and library. Color wheel. This is also closed. Rather than renaming anything, we can make color wheel a native CircuitPython module. So does that exist in this? No. Adafruit color wheel. Rainbow. Rainbow IO. Rainbow IO. What does that look like in the docs? Boy, that's a bummer when you're trying to go to this page and it's like, that doesn't exist. You're like, take me back to the beginning then. Rainbow IO. Rainbow IO. Feel like we're close. Yeah, Rainbow IO color wheel. So from Rainbow IO import color wheel as wheel. And then this should run. Yeah. So it's not doing anything, obviously, because I don't have NeoPixels hooked up. So maybe I'll test this. Maybe I'll grab one of my strips. And I don't think I have a 96. That's probably the most dense one, but I have one with at least 30 or something. I could change this to 30 and plug it in and just make sure that it does something. I don't know what it's supposed to do. Let's look at what it's supposed to do. NeoPixel wave. Oh, I have one of these neon strips, actually. I don't know how many pixels are in it. Printed out a heart shape that it fits into. Maybe I'll show that one of these days. Okay. Yeah. I'm not going to test it right now because I don't have the hardware ready to go, but I will test it out eventually. What I will do though right now is I will fix code, which is also, I should add back to here. This does not seem to be backwards compatible. Doubt it affects libraries. Maybe some examples. Definitely learn guide code as we just saw. Does need to be tested. It's sort of in progress. I changed one thing. Okay. None of that's done yet. There we go. Is it implemented? Yeah, I guess it is, right? Because we have the new version already. And it does break some code. I don't think there's that much code out there that it breaks, but... Okay. I'll remember to come back and do it. Okay. This is louder than the rest that I was listening to, so I'm going to turn it down. So we're going to copy this. We're going to put it back into the repo. And waterfall is the last one, which is using display IO. Like in a rolling graph. Runs on the clue. We'll test this one out. So FFT and vector. Let's put that back. Even though we're going to override it in a minute, but that's all right. ulab.numpy as np dir np. We have vector eyes. It's probably different. So we need to find vector. FFT is here. Lab dot. Array we know, FFT we know. Vector we need to find min max. Those are probably numpy, right? Min max, yep. Array we know. Okay, so vector is the last one we need to find. This is actually just saying vector log, so is it actually log right here is probably what it is now. So we don't need any of these. Numpy as np. np. P should just be doing replace, huh? Oh no, I can't replace these ones. P. 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 One more. And P right here. Copy this. But that's not getting covered by the chat. I'm not actually sure. No spectrogram. Where did we find that? I thought that was... Okay. So is it inside of FFT? Well, it's not because it's not finding it, right? I thought we found that before, spectrogram. Was that just on Numpy? I don't remember now. No, this is like a function. Well, no, this is a class, I guess. I don't know. I think it's not. It's in signals. Was that the one that was in signals? It's actually signal though, right? No? SciPy. SciPy. Then signal. And that's where it's at. Spectrogram. So let's go from ulab dot scipy dot signal import spectrogram. Maybe I spelled it right that time. We'll see. No. I did not spell it right that time. Right, I can't copy out of here now. Well, I can, but I can't do it using the key combination that I'm used to using, which is Shift Control C in that order. But now only Control Shift C works. The order that you do Shift and Control matters now, but it didn't used to. Did I spell something else wrong? Oh. Yes. We changed this. We need to also update where it's used. I should be doing this in the repo, honestly. Okay. There we go. Yeah, and it seems like it can hear me talking because it's a microphone. So I don't have a great way to, maybe I can... Yeah. All right, that seems to be working. That's a cool one. I never ran this one before. That's really neat, though. I could sit here and stare at this for more time than I really should, I'm sure. Okay. So we copied out of here. It worked. This one's fixed. So I'm gonna push these, but I'm not gonna make the PR yet. I'm gonna test this LED wave one before I make the PR. But I'm not gonna do that on the stream because I don't have the stuff ready to go for it. So I'll test that one probably a little later today or maybe tomorrow morning or something. Once it's tested, then I'll make the PR. Inside the PR, I'm going to note that we fixed the barometer and the pulse example by having them do data equals, that roll thing. Also inside the PR, I'm going to note that we changed the import of wheel to go inside of Rainbow IO, which is where it's at now. So now that I've said that out loud, hopefully I will remember all of that. I think I will. But I think that is going to be it for today right now. So I'm going to go ahead and wrap it up. I will, like I mentioned towards the beginning of the stream, though, if there's new folks around, I will be streaming on CircuitPython Day at the same time I normally stream on Saturday. So I normally stream at 10 a.m. Central on Saturdays. So I will be streaming at 10 a.m. Central on Friday this week, the 6th, CircuitPython Day, which is 11 a.m. Eastern, which is the time zone most of the rest of the CircuitPython Day festivities are advertised in. So 11 a.m. Eastern, Friday the 6th, I will be streaming something. I'm not sure what yet. But that's going to be it for today. And yes, I definitely second that. Thank you, Lay Samurai. Everybody, I hope that everybody has a good weekend and a good week. And I will see you all next on Friday. So thanks for tuning in. I appreciate it. And for all the help that everyone gave me. Definitely was a huge help, everybody in the chat. So thank you.